The wind sweeps across a vast, gray expanse of steel, a floating city stretching longer than 3 football fields. This is the USS Gerald R. The largest and most advanced warship ever constructed. Its power is visible in the sleek lines of F-35C Lightning II jets lined up on its flight deck, or in the 4,500 sailors who call this 100,000-ton behemoth home. But true dominion is not worn on the sleeve, it is generated in the heart. Deep within the ship's armored citadel lies the source of its impossible might, a propulsion plant. It is less an engine and more a contained piece of the sun. To understand how this leviathan moves, we must descend into the reactor rooms and examine the A-1B nuclear reactor. A marvel of engineering that has liberated the American carrier from the tether of logistics. And like oil-fired giants, the Gerald R. does not burn fuel, it moves because it boils water. The principle is simple, a dance as old as the Industrial Revolution but fueled by the atom. Within the heart of the A-1B reactor, enriched uranium-235 atoms are split in a controlled fission chain reaction. This process releases an immense amount of heat. The USS Gerald R. is equipped with 2 A-1B reactors, built by Bechtel Corporation. They represent a quantum leap over the A-4W reactors of Nimitz-class carriers. While a Nimitz carrier requires refueling once in its 50-year lifetime, Ford-class reactors power the ship for its entire 50-year service life without refueling. This heat is transferred to a secondary water loop, turning it into superheated, high-pressure steam. The A-1B is estimated to have a thermal output of roughly 700 megawatts per reactor, about 25% more than its predecessor. In total, the ship harnesses nearly 1,400 megawatts of thermal energy. To put that in perspective, the electricity generated is enough to power a small American city. Some of this steam is directed to massive turbine generators, creating an electrical plant capable of producing 125 megawatts of power, more than triple the electrical capacity of the Nimitz-class. This surplus of electricity is the secret behind the Ford's revolutionary capabilities. It is the reason the ship can replace steam-powered catapults with the Electromagnetic Aircraft Launch System EMALS, where steam catapults are violent, rigid, and inefficient. EMALS uses a linear induction motor to accelerate a shuttle, providing a smoother, more controlled launch that is easier on both the aircraft and the pilot. It can launch heavy fighter jets and light unmanned drones with equal precision, allowing for 25% more sorties per day. This insatiable hunger for electricity also powers the Advanced Thrusting Gear AG, which uses electric motors and water turbines to catch landing jets with a softness that old hydraulic systems could never achieve. Yet, for all the complexity of the launch and recovery systems, the primary job of moving the ship itself falls to the remaining steam. That steam is channeled to the 4 massive bronze propellers, each 21 feet in diameter and weighing 30 tons. The turbines spin the shafts with enough force to push 100,000 tons of steel through the water at speeds in excess of 30 knots. This speed, sustained indefinitely without regard for fuel consumption, is what gives the carrier its strategic agility. It can be ordered to the far side of the globe and arrive in a matter of days, ready for combat the moment it arrives, but the analysis of this engine cannot stop at propulsion. The A-1B reactors are the life support for the entire floating metropolis. They generate the electricity that lights the berthing compartments and powers the desalination plants, which distill 1.5 million liters of fresh water from the sea every day for drinking, cooking, and washing. They power the galleys that serve thousands of meals, and the radar systems that watch the skies for threats. The reactors also provide the immense power required for the 11 advanced weapons elevators, which use electromagnetic motors to lift ordnance from the magazines to the flight deck in minutes instead of hours, allowing the air wing to generate a relentless tempo of combat power. The true genius of the Gerald R. engineering is not in moving a massive object, but in creating a self-sufficient ecosystem. The engine provides propulsion, but more importantly, it provides persistence. It allows the ship to be a sovereign American territory, capable of projecting power anywhere in the world for decades. Limited only by the food its sailors can eat and the resolve they can muster, the roar of an F-18 launching into the night is the sound of American air power, but the silence beneath it the silent, fissioning heart of the A-1B reactor is the reason that sound can be heard in any ocean on Earth.